Good morning students. Now we discuss about the exercise 10.8 problem number 9. So you see the questions, you read the questions. A pot of boiling water at 100 degrees Celsius is removed from a stove at time t equal to 0 and left to cool in the kitchen. After 5 minutes the water temperature 80 degrees Celsius and another 5 minutes later it has dropped to 65 degrees Celsius. Determine the temperature of the kitchen. So you see here a pot of boiling water. So a pot of boiling water, its temperature is boiled by 100 degrees Celsius. Is removed from stove. So it is taken from the heat. So and removed the heat. So at the time is t equal to 0 and left to the cool in the kitchen. After 5 minutes the water temperature 80 degrees Celsius. That means I cool the water. After the 5 minutes the temperature comes to 80 degrees Celsius and another 5 minutes later it has dropped to 65 degrees Celsius. After the next 5 minutes I cool the water, it comes to 65 degrees Celsius. Determine the temperature of the kitchen. So they ask about the temperature of the kitchen. So now in this problem we will find out the temperature of the kitchen. So you see here, let capital T be the temperature of the boiling water. Capital T here, capital T I represented by temperature of the boiling water at the time T. S be the here, capital S be the room temperature. So next, so therefore the rate of the water temperature is proportional to T minus S. That means dt by dt proportional to T minus S, which implies dt by dt equal to K into T minus S, which implies now the next step I separate the terms. That means I grouping the terms separately. So the t terms, capital T I grouping in left hand side, small t I grouping in the right hand side. So I write it capital dt by t minus s equal to k into this small dt I write in the left hand side. So I write it k into dt. So the next step you see here, capital T I grouping in the left hand side and the small t I grouping in the right hand side. So the next step I taken the integration on both sides. So integral dt by t minus s equal to integral k into dt. So now I taken the log, that means the integration of the 1 by t minus s is, this is the integration of 1 by s is log x. So this is also x. So integral 1 by t minus s is log of t minus s equal to k is a constant. I write in the outside and integral of dt is t. So kt plus c. Therefore, the next step log of t minus s equal to kt plus c. In the next step I taking the exponential on both sides. So e power log means e and log cancelled. So t minus s equal to e power kt plus c. So I separate the power. E power kt into e power c. E power c is the constant. So again I write it c into e power kt. So t minus s equal to c into e power kt. This is the equation number 1. Now I take when t equal to 0. So when t equal to 0 and capital T equal to, now the water initial temperature is 100 degrees Celsius. So capital T equal to 100. So I substitute here. That means the small capital S room temperature is here. We don't know the room temperature. This is we find out this. This is our question. Determine the temperature of the kitchen. So the temperature of the kitchen is capital S. Then we will find out this. So the temperature of the water is 100. 100 minus S equal to C into the initial time is 0. So therefore C into e power 0. So which implies e power 0 is 1. So C equal to 100 minus S. So therefore you see here, that means T minus S equal to, now I substitute the C values in equation number 1. So T minus S equal to, the C value is 100 minus S into e power kt. So therefore next they give that after the 5 minutes the water temperature is 80 degrees Celsius. So T equal to 5 and T equal to 8, capital T equal to 80 degrees Celsius. So I substitute in the equation number 1. So that means here I substitute here. So 80 minus S equal to 100 minus S into e power, the T value is 5k. The T value is 5. So the next step, e power 5k equal to 80 minus s by 100 minus s. So next after the 5 minutes, already I take the 5 minutes. After second time 5 minutes, totally 5 minutes plus 5 minutes, 10 minutes. So after the 10 minutes, the temperature, the water temperature is 65 degrees Celsius. So capital T equal to 65 degree. So capital T equal to 65 degree. So which implies, I substitute capital T equal to 65 in this equations. Capital T equal to 65 minus S equal to 100 minus S into e power, the T value is 10k. So therefore 65 minus S equal to 100 minus S e power, this 10k I write it e power 5k whole square. So you see here 65 minus S equal to 100 minus S into 80 minus S whole square by 100 minus S whole square. So which implies 100 minus S cancelled. So 65 minus S equal to 80 minus S whole square by 100 minus S. So you just doing the cross multiplication. 65 minus S into 100 minus S equal to 80 minus S whole square. So I multiply this. 65 into 100 is 6500 minus 65 into S is 65S. Next minus S into 100 minus 100 is minus into minus plus S square. So the next step, that means 60,500. So 60,500 minus 100 is so minus 65. Yes. So totally that means so now I apply the a minus b whole square. A square minus 2ab plus b square. So I write it 80 whole square is 6400 minus 2 into ab. So 2 into 80 into s. So that means minus 160s plus s square. So in the next step I write it is 6500 minus, I add this. That means minus 100 is minus 65s is minus 165s plus s square equal to 6400 minus 160s plus s square. So the next step 6500 minus 165s equal to, that means I write it, this is a here 6400 minus 160s, that means the s square cancelled, both sides are s square, I cancelled this. So 6500 minus 165s equal to 6400 minus 160s. So the next step we write it, that means 6500, I write all the terms, that means 6500 minus 6, this is 6400, I write in the left hand side. So minus 6400 equal to 165s minus 160s. So which implies I write it, this is a 5s equal to 100. So therefore S equal to 100 by 5 is 20 degrees Celsius. So the kitchen temperature is 20 degrees Celsius. This is the answer for our problem. The problem you see here, a tank initially contains 50 liters. That means we know that the tank, its water volume is 50 liters. So of pure water starting at time t equal to 0, a brine containing with 2 grams. So a brine, that means a brine containing with 2 grams of dissolved salt per, that means the salt per liter flows into the tank at the rate of 3 liter per minute. The mixer is kept uniform by stirring, that means stirring, and the well stirred mixer simultaneously flows out of the tank at the same rate. Find the amount of salt present in the tank at any time t greater than 0. You see here, that means x of t denote the amount of salt in the tank. So dx by dt equal to flow rate minus outflow. So inflow minus outflow. So inflow rate is, that means here they give the inflow rate is 2 into 3, 6. So here you see here the tank, it has the number of liter is 50 liter. And the next is starting at a time t equal to 0, a brine containing with 2 grams of dissolved salt per liter flows into the tank at the rate of 3 liter. So 2 gram for 3 liter. So 2 in flow rate is 2 into 3, 6. So next the mixer is kept uniform by stirring and the well stirred. So here you see here, now I separate the terms. That means dx by x minus 100 equal to minus 3 by 50 dt. So in the next step, now I taking the integration on both sides. So integral of 1 by x minus 100 dx equal to minus 3 by 50 into integral of dt. So integral of 1 by x minus 100 is log of x minus 100 equal to, that means integral of dt is t. So minus 3 by 50 into d plus c. So I take the log on both sides. So then I take the exponential on both sides. So the exponential of log of x minus 100 is cancelled. The exponential and log cancelled. So x minus 100 equal to, that means e power minus 3 by 50 into t plus c. So I separate the power. So e power minus 3 by 50 into t into e power c. E power c is capital C. So capital C into e power minus 3t by 50. This is the equation number 1. You see here, when t equal to 0, x equal to 0, from equation number 1 I substitute. So 0 minus 100 equal to c into e power 0. So therefore e power 0 is 1. C equal to minus 100. Therefore x minus 100 equal to minus 100 c e power minus 3t by 50. So in the next step, this minus 100 I write in the left hand side. So 100 minus 100 e power minus 3t by 50. So the next step, x equal to, that means here 100 is common. So 100 is common means I take outside. So I write in the outside 100 into 1 minus e power minus 3t by 50. This is the x values. X values for the, that means amount of salt. The amount of salt is this, x represents the amount of salt. Therefore x equal to 100 into 1 minus e power minus 3t by 50. This is the answer for this problem. We complete the class.